Well, hello. This is Miss Townsend, and I love math. Welcome to Math with Townsend. This video is for grade 10 academic students who are working on their summative, and this is question number 18. Now, okay, technically the worksheet says 17, but you'll notice that there's two question number 17s, so I assume that means this is actually question number 18. And so, yeah, this is supposed to be question 18. It's the one with this terrible looking shape. So determine the perimeter of the hexagon to the nearest centimeter. So a hexagon is just a six-sided shape. 1, 2, 3, 4, 5, 6. Yep, definitely a hexagon. And if I want to find the perimeter of the hexagon, I need to find the length of each of those red sides, right? So this is going to be a fairly complicated question, but obviously it involves a lot of angles and trigonometry. You can see that that this hexagon has been divided into 6 differently shaped triangles. So our job is going to be to keep careful track of what we're doing and eventually find the length of all of these red lines. So if you look carefully at that diagram, which triangle do I know the most information about? Because that's the triangle I want to start with. Well, I only know one angle, and that's that 60-degree angle right there. And therefore, I know the most information about this triangle right here. So that's the triangle I'm going to start with. And I never like to work with triangles or any other shapes unless I've identified or labeled the vertices. So I'm going to call this A, B, and C. And as I go through the whole question, I'll keep labeling things. Oh, let's do it now. D, E, F, and G. So everything has a label, so when we're talking about it, we know what to call it. Okay, so here's the image again, except for this time I've made it a little neater with my labels. And again, the triangle that we know the most about is this triangle here. And we can now give it a name, right? It's triangle ABC. And I know a lot of information. So I know, and I'm going to just redraw that triangle over here, right? Just so that I can see very clearly what's going on. So here's triangle ABC. This side is 5 centimeters, this side is 6 centimeters, and this angle here is 60 degrees. And that's enough information for me to use the cosine law. When I use the cosine law, I'll be able to tell you the length of this side, which I'm going to label right now as tiny little a. Okay, so let's do this math. So a squared equals b squared plus c squared minus 2bc cosine big A. So a squared equals 5 squared plus 6 squared minus 2 times 5 times 6 times the cosine of 60 degrees. So a squared is 25 plus 36 minus 2 times 5 times 6 is 60 cosine 60 degrees. Okay, so keep going. So 25 plus 36 is 61. And the cosine of 60 degrees, cosine of 60 degrees is 0.5. Oh, I knew that. Of course I did. Anyway, so it's 61 minus 30. So a squared is 31. And therefore a is the square root of 31. Oh, I lost my calculator. There it is. So the square root of 31, where's square root? Do, 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 do. Do. Isn't that funny? I never use this calculator. I just want it to kind of work together on this question. I feel like I'm in a terrible game show. I can hear the audience screaming at me, "It's right there! It's over there!" All right, well, I still don't know, so I'm going to do it the really mathematical way, which is putting to the exponent a half. Don't worry about that. You guys all have calculators. So I get 5.6. Okay. Excellent. And I guess we're measuring in centimeters, so that's the measure of, go back up here. I now know the length of this side is 5.6. Okay, so what else do I know? Oh, well, let's go to a clean page here. And we'll grab this lovely picture. So what do I know? Well, I now know that this is 5.6. And therefore I know that this is 5.6 because they were marked with these similar identical side length markers. So have a look now at triangle AGB. So let me try to copy AGB over here. A, G, and B. I know that this is 1, and this is 6, and this is 5.6. What am I going to do with that information? So because I have all 3 side lengths, I could find any angle I want. So let's look and see which angles might be useful. I don't know about these, but look at this angle. If I could figure out what this angle is, I can use that information and this straight line to find the length of this angle. So do you see that? Let me try to show that again. So erase, erase, erase. Get all that other information off of there, and I'll use my zoom in tool and see if I can make this work. No, it didn't work. Okay, one more time. Excellent. Okay, so if I can find this angle here, so I don't think I can write with pen on zoom in, but if I could find the measure of this angle, oh, it's kind of wavy gravy. If I can find this angle, then this angle here is 180, and I'll have 60 plus whatever this is, and that'll help me find this angle. Now, it's entirely possible that all of these angles are 60, but I hate making assumptions, and you can't make assumptions. You have to verify mathematically if that's a true concept. So I am going to find this angle here. And again, the way that we find angles, well, I have the 3 sides, so I have to use the cosine law. So using the cosine law, the angle that I want is angle A. So therefore, I'm going to have to use this. And again, I'm going to call this side little a. So I'm going to have to set up this cosine law. B squared plus c squared minus 2bc cosine big A. Okay, so now this time I know that little a is 5.2. So I'm going to have 5.2 squared equals b would be 1, so 1 squared plus 6 squared minus 2, 1 times 6 times the cosine of a. So that this video isn't infinitely long, I'm going to press pause here. I'm going to do math without you and trust that you can kind of follow along in your calculator. Okay, so I did the math, and if you want to press pause, you can kind of see what I'm doing. Basically, I'm just using the cosine law, and I got a value for angle A of 33.9 degrees. So this angle here is 33.9 degrees. So let's go to the next screen, clean this up, and see what our next step is going to be. So we know that we have 5.2 here and 5.2 here. And now we know that this angle here is, what was it? Sorry, 33.9. So this is 33.9. So I want you to focus for a minute on, again, this area right here. And in particular, let me kind of redraw what I want you to be looking at. This is the point we called A, and we were told that this was 60 degrees. And we've now calculated that this angle is 33.9. Now, this is truly a straight line, which means that it's half a circle. And half a circle contains 180 degrees. So therefore, this angle here is going to be 180 minus 60 and minus 33.9. So these two angles together are 93.9, which means that missing angle right here must be 86.1 degrees. Excellent. So now I have 86.1 degrees in this angle here. So how does that help us? Well, let's take a look. Zoom in magic. So In this little baby triangle here, we have a 1 centimeter side, a 2 centimeter side, and now we know the interior angle is 86.1. And with that information, we can use the cosine law to tell us what the length of this side is. So that's our next step, and we'll do that on a nice new clean piece of paper. So again, pulling my picture up. So we know, and again, I like to draw the thing I'm dealing with separately. So here's that tiny little triangle, AGF. I have, this is 1, this is 2, and we've just discovered that this angle here is 86.1 degrees. And now I can use the cosine law to find the length of this side. So I'm going to press pause. I'm going to do it without you, and I'm sure you can check on your calculator that you get the same answer I did. Okay, so I did the math, and I got a value for that side of the triangle of 2.2. So again, this side of the triangle is 2.2 centimeters, and that means this side of the triangle is 2.2 centimeters. Good. So where do we go from here? Okay. What do we know? We know that this is 5.2, 5.2, 2.2. We know this angle, and this angle. Now, I see another straight line. See this straight line? That must have a sum of 180 degrees. And I know this piece and this piece. So I can, again, use the 180 rule to find this piece. So let's do that on the next piece of paper. So again, nice clean picture. And so if we zoom in, well, we're not going to zoom in because we're running out of time. We learned that this angle here was 33.9. And we learned that this angle here was 86.1. And therefore, we can find this angle here by doing 180 minus the sum of those two angles. And we're going to get 60 degrees. We also knew that, actually, we knew that I could have done that much faster by using the opposite angle theorem, which tells me that this angle here is opposite this angle here, so they must be the same. Okay, so now if we look at triangle AEF, here it is, AEF, we know that we have a 60-degree triangle. This is 2, and this is 3. And again, we can now use the cosine law to find the length of this side. So again, I'm going to press pause. I'm going to do the math, and we'll come back when I have an answer. Okay, I'm back. So I used the cosine law, and I found that this was the length of 2.7. So where are we now? Next page. Now we're getting there, right? And hopefully you're seeing kind of the flow. So now we have the next triangle that we're going to look at is ADE. And I know 3 and 4, and this angle here is opposite this angle here. So this, which was 33.9, must be the same as this, which is 33.9. So again, we're going to use the cosine law. So here's the triangle in question, DEA. This is 33.9. This is 4. This is 3. Use the cosine law again and find the length of this side. Okay, so I used the cosine law and I got a length of hold on, what did I get? 2.3 centimeters. And we're almost done. We have one more triangle to go. And again, 4 centimeters, 5 centimeters. This angle is opposite this angle. And we already discovered that this angle here was 86.1. So this angle here is 86.1, and therefore let's go to a clean page where I can actually see what I'm writing. We have this triangle, CDE, and we know 5, 4, and 86.1. So use the cosine law and find the length of this side. Okay, so I get a side length of 6.2. So let's put it all together. So these are all the values that we calculated for the perimeter. Add them all together, I get 23.8 centimeters. I guess that wasn't so bad. It was just kind of long. I hope that helps, and please ask if you have any concerns.